principle, we need to know standard deviation. For quantile, we need to know the data itself, so just the higher order of quantile. Alright, so next thing is the maximum and minimum principles. First, consider things from the point of view of an individual exposed to a possible loss and seeking insurance cover against that loss. Suppose the individual adopts the utility function UX and has wealth W. Then we have also a couple of assumptions, and there are two expected utility with no coverage and with coverage. So with no coverage, this is the left hand side, and with coverage is the right hand side. Okay, and the only possible chance that the individual will buy insurance if the coverage from the insurance, if he buys insurance, is more, the utility is more than the expected utility he has without buying the insurance. More equal. Okay. And when the premium increases, of course, this value will decrease and the utility of buying insurance will decrease. So if insurance company will try to make the insurance premium high enough, then it won't be gainable for the insurer for an insurable to buy this insurance, okay, to buy this policy. So here, what is satisfied? We have some Pmax. We increase this. We have increased this P, and we have the Pmax, such that the utilities are equalized. And this is the Jensen inequality, and we know that Pmax should be more equal to the expected risk. So this is just the simple argument. Pmax should be more or equal to P minimum and should be more or equal to expected S. Okay, against a major loss. All right. Okay, so this is the same case, but from the point of view of insurer. Okay, before that it was from the point of view of individual. Now it is from the point of view of insurer. And insurer also has its own utility function, and he will be providing cover only if the expected value of expected utility of providing cover is greater than expected the utility of not providing the cover. Okay, the same principle stands here, and we have this P minimum. This is the minimum price on which he agrees to sign the contract. And also here should be applied also the Jensen inequality. Here it is. So P minimum should be more or equal to expected value of risk. And if we combine insurer and the individual, so we will end up with this thing. So maximum amount that insurer agrees to buy should be more than the minimum price that the insurer would like to receive from the individual, and they both should be more than the expected value of risk. So in this case, the individual may not the individual may not underestimate the amount of risk, and tries to make everything that the risk will go down. In the other case, he would be pushed to buy the contract, to buy the coverage. And the same happens with the insurance company. Insurance company is also interested to make the risk as low as possible to get the maximum gain from the premium. Okay, so here very simple theory that only inside these borders the contract can be signed. If premium is higher than the maximum value of Pmax, then the contract won't be signed because insurer wants more money than the individual would agree to give. And the same happens in the opposite way. Alright. So we will continue now the task we have just solved. We are using the same simulated data. The party to be insured has initial valve W and uses a utility function in the form of exponent with beta equals 0.005. Okay. So we have to find the Pmax. Great. In order to solve this thing, we need to apply the moment generation function for Poisson distribution with a rate parameter 0.1. It was given in the previous task. And okay, this moment generating function will give us m. Okay, let us move to RStudio. Okay, task 6. So what we know? We know that ux is minus exponent minus 0.005 x. This is the thing we know. We also know the parameter for the MST for a Poisson distribution. This is expected value of exponent TS, and this gives us exponent T equals to 0.1. From the previous thing, it is equal to lambda, so it will be 0.1 times mx t minus 1. This is our moment generating function for x. mxt, how to find mxt? We're going to use it. Okay, t equals 0.1. m will be 1 minus 100 times t to the power of minus 1. Okay, what else? T and m. So m is this value. Okay, why t is 0.1? I don't get it. No, t is 0.005. Sorry. T is this value. T is this value. Okay. Okay. So what is the idea? Why m? Yes, m is 2. Okay, we have found that m is 2. Now MS. This was actually MX. MS. How to find MS? We will need to use the exponent of 0.1, I guess. MS is 1.1 something. And from MX and MS we need to find the Pmax. So we just need to use the equality. Exponent of 0.005 p equals to this exponent of 0.1. Okay, so from this equality we can find this Pmax. Okay, let's extract. Because these are exponent and exponent, then we can get rid of this exponent, and 0.005 p will be 0.1. So Pmax is 0.1 divided by 0.005. Is it correct? So Pmax is 20. Pmax is 20 in this case. And yes, what is the condition to buy the insurance? So Pmax should be more than expected value of S. And this is true because ES expected value is 0.1 times 100, and this is 0. This is 10. Okay, so Pmax 20 more than 10. Pmax more than ES. More than 10. Alright, so this is how it is calculated. We just need to know the moment generating function for MS and for MX. So for MS it was the exponent of this, and then we extracted MX moment generation function for X, and then calculated Pmax. So the result, the insurance contract will be signed.